All right, pre-cal, we're going to talk about our inverse functions, and the first thing we're going to start with is the horizontal line test. So we know with the vertical line test, it tells me if a function is, it tells me if a relation's a function if it passes the vertical line test. But let's say we have a parabola here. Now I know that my parabola is a function, but what the horizontal line test does, it helps me decide if the inverse is a function. So if I draw a horizontal line through here, notice that it crosses it twice. So this means that the inverse of my parabola is not a function. So that's how the horizontal line test works. So I want you to look down here in your notes. It says to graph the following functions in your graphing calculator and determine if the inverses are also functions. So I'm going to show you this graph. It's the absolute value of x minus 1. And I'm going to show you this cubic function right here. So I've already got these in Desmos. So this is what this would look like. So I can't write on these, but I just want you to look at the red graph. That's my absolute value function. And if you'll notice, if we were to draw a horizontal line through it, it would cross in two places. So the inverse of this first equation is not a function. But if you'll notice my cubic function, the blue function, if I were to draw a horizontal line through that, it will only cross it in one place. So the inverse of that function is a function. So just keep that in mind as we move along here. So if a function passes the horizontal line test, then it's said to be a one-to-one because each unique value in the domain has a unique value in the range. Sorry for my messy handwriting. I'm tired. Okay, so if we look at this table of values right here, and if I wanted to find the inverse for these, what it would look like is this right here. The inverse just means that all my x and y values just switch. So all of these x values now become the y values, and all of the y values become the x values. Isn't that magical? Okay, now when we look at this, we're looking at our x values. Since they've become the y values, I want you to notice that now 5 repeats. That means that the inverse is not a function. Oh, I've just erased. Poopy. Inverse is not a function. Groovy. All right, so let's see what this looks like graphically. When you're looking at the graphs, draw in the inverse and determine if they are functions. Okay, so how would we determine that? Well, I'm just going to pick a few of the ordered pairs here, and we're going to find their inverses, okay? So this first ordered pair is 0, 4. So if I switch that, that gives me 4, 0, which is right there. And then let's look at this one over here. It's negative 2, positive 2. So if I switch those, that becomes 2, negative 2. So that's right there. And then the origin is 0, 0. It just stays that way. So part of my graph would look like this. And then these other values over here, this one right here is 3, negative 2. So if I switch that to negative 2, 3, it is up there. And this one down here is 0, negative 4. So if I switch that, I get negative 4, 0. So it's right here. So then my graph looks like that. So that's the inverse. And if you'll look at that, you can tell that the inverse is a function because it passes the vertical line test. Could we have just done the horizontal line test on the original? Yes, we could have. Same thing. Okay, so now this next one, we've got some ordered pairs here at -3, 3. So if I switch that and it becomes 3, -3, it becomes this right here. And then here's an ordered pair at -1, 2. If we switch that and it becomes 2, -1, that's right here. And this one down here is at 1, -2. If we switch that to -2, 1, it's right up here. So there's the inverse, and this inverse is also a function. Magic. Okay, so we're going to do the next examples in another video.